Welcome back to the course on Instrumentation and Process Control. Myself, Neeti Mehta, Assistant Professor at Chemical Engineering Department, LJIET Institute of Engineering and Technology. So, let's just start with today's topic. If you recall what we have covered in our last topic, you must remember that we have seen what do we mean by control system and what are basic control system, right? We have seen that how we can classify a control system based on its action. So, based on action of control system, we can classify them into two different categories. First one is open loop control system. In case of open loop control system, the output of system or the output given by the system is independent of our control action. Whereas in case of closed loop control system, the output will be dependent, right? So, let's just start with the closed loop control system. If you see the definition, by definition, a system in which control action is somehow dependent on the output is called as closed loop control system. So, what do we mean by this definition? So, if my output of the system is dependent on the control action, right? If my controlling action even control the output given by the system, then it is termed as closed loop control system. Let's take the example of closed loop control system. So, first example, as you can see in this particular picture, is our iron, right? So, if you recall, the purpose of iron machine is to give clothes proper ironing, right? So, whenever we are setting our ironing machine in any given range, whether we are setting it for the clothes of cotton or of silk or of any other kind of material, so depending on your selection only, it will provide that much amount of heat. Right, and even once it provides that much amount of heat or the element of heating of iron machine is heated to that much amount, then it cut off the heat. Once again, if the heat level is going to reduce, then again it will switch on the heat and again provide that suitable amount of heat, right? So, the action, that is heating, is directly controlled by the system or by the mechanism. That's why it is known as closed loop control system, correct? Now, one more example of closed loop control system is quite very common, and we are oftenly using this equipment in our workplace or at our homes. It is our air conditioner, right? So, if you remember, the duty of air conditioner is to provide suitable temperature so that you can get a healthy and comfortable atmosphere, right? So, what we do is we just give it some temperature or we just set some temperature in our air conditioner. Suppose we are setting a temperature of 24 degree. So, what will a air conditioner do? It will reduce the temperature of our room to 24 degree, and once it achieves that temperature of our room, it will cut off the power supply or it will just switch off, right? Again, when it senses that temperature is falling down or it is exceeding 23 degree, then again it starts working to achieve that 23 or 24 degree centigrade, whatever temperature you have set. So as you can see in both the cases, what we are doing and what we are getting. We want output and we are setting some input, and based on that input only our output is also controlled by our system. Correct. So this is the example of closed loop control system, and this is how our closed loop control system works. Now let's discuss what are advantages of closed loop control system, right? Because whether to select an open loop or a closed loop, we must first have a clear picture in our mind that what are advantages and what are disadvantages of system which we are going to select. So the first example of closed loop system is it is more accurate. So it is more accurate as compared to open loop system. Why it is more accurate? Because we have seen in case of open loop system, our output is unbounded. So we cannot control our output or what we are getting from our system. But in case of open loop system, the entire thing, input, output and rest parameters, each and everything can easily be controlled. We are having hold over our output also. So we can easily control our output, and that's why it is more accurate. It will precisely give you your output. Coming to the next advantage is highly accurate, as any error arising is corrected due to presence of feedback signal. Now in case of closed loop system, what we are doing is we are comparing both the values. We are comparing the input given by you or the desired value what you want, and we will compare the output given by the system. When we compare both these values, we will get a feedback or an error, right? And using that error, we can easily correct all our system from any kind of undesired output. For an example, if you have set AC at 24 degrees centigrade, so 24 degrees centigrade is your desired input which you are giving it. You want 24 degrees centigrade as output from your AC. So what you will do is, you will sense the output temperature, you will measure the output temperature, then you will compare your output with the input given by you. Suppose output is coming to be 26 degrees centigrade. So 24 and 26, when you compare both of them, there is a difference of -2 degrees. So this is the error which will be corrected by our air conditioner, and it will reduce -2 degree temperature for our room. Next is sensitivity of the system may be made small to make system more stable. So what we can do is, sensitivity can be manipulated so that system can be more stable. Sensitivity refers to we can use a system in wide range. So if there is a change in plus or minus 0.5 or 0.4 degree, then our system is not going to change it, right? Next is bandwidth range is quite large, means it can work over a quite large extent. We can have a large range of working scale. It can facilitate automation. It means that it supports complete automation. We can completely automate our system if it is a closed loop system. Let's discuss disadvantages of using closed loop system. The first disadvantage of using closed loop system is it is quite costlier, right? As compared to open loop system, it is costlier. It is quite obvious that since there are much more parameters which are being incorporated in our system, that's why cost has been enhanced. They are quite complicated to design, so it is quite obvious that when you are dealing with more than one or two parameter, the complexity of your arrangement is going to increase. The more parameter you need to control, more complex structure you are going to deal with, right? So the complication is with designing part, because there will be quite complex structure and complicated design has to be done. It requires quite more maintenance. Why it requires more maintenance? Just because it has more element to deal with. It has completely automated system, so the maintenance part is going to be quite large. Next is, due to the feedback, oscillation response increases. It means that since we are comparing our output value to the input value which we have given, due to that feedback given into the system, the oscillation increases. Oscillation refers to change in values, or when the system is trying to make itself more stable, right? So it is going to get oscillatory due to this particular feedback given into the system. Overall gain is reduced due to presence of feedback. Since feedback is incorporated into our system, so the gain of the system is going to reduce. And the last is stability. When we are dealing with feedback, stability becomes a very important part, because even if there is small change in outlet value, then also there will be a error generated, and once error is generated, our system will try to overcome that error, and this complete cycle will lead to generation of instability of our system. Correct. So this entire thing become quite unstable. So whenever we are dealing with closed loop system which is having a feedback in it, then stability is a major criteria we need to consider or we need to understand, right? This is all about closed loop system. Now let's just see one more topic, which is servo and regulatory problem. When we are talking about problem, there are two kind of problem which you need to handle in your closed loop system, right? First one is servo problem. In case of servo problem, what happens that our set point is continuously changing. In some chemical industry or chemical process, we might need to change temperature of our equipment as function of time. We might need to change our temperature in certain time interval. So in such cases, there will be an problem in case of stability. How it can create problem in stability? Because each time the temperature changes, due to the feedback, error will be generated, and once error is generated, the entire system will become unstable. So servo problem deals with change in set point, and in case of servo problem, your load or outer disturbance will remain as it is, right? So servo problem is a problem which is generated due to change in set point, and it does not have to deal with any kind of load, because load will remain as it is. Next category of problem is regulatory problem. So when we are talking about regulatory problem, what happens in case of regulatory problem? In case of regulatory problem, there is a change in load. So what happened in regulatory problem? Outside disturbance is changing again and again. Suppose outside disturbance is changing. So once it is changed, my system try to incorporate that change into it, and it is stable now. After some time, again some disturbance is caused in outside atmosphere, and due to that again my system is unstable, right? So whenever there is change in load, it is termed as a regulatory problem. And in case of regulatory problem, set point remain constant. There is no change in set point. So always remember, whenever there is a change in set point, it is termed as servo problem, and whenever there is a change in load, it is termed as regulatory problem. Correct? So this is all about today. Hope the topic is clear. Thank you.